Write the given differential equation as a first-order system using matrix notation. This is really cool because we can rewrite this in terms of a first-order linear system, which sometimes might be a little bit easier to deal with. So the first step that I would do is I would leave the highest order derivative on the left and put everything else on the right in increasing order of derivatives. So t cosine of t minus 4y. Then I'm going to say that my y is equal to x1, x sub 1. And now my y prime will be equal to x2. So let me write that close to the y. My y prime, which is not even present in here, is equal to x sub 2. Now let's do some derivatives, and let's say that if I take this original y and I take the derivative of it, that's going to be equal to x1, the derivative of x1, which is going to be equal to x2. And if I take the derivative of this one right here, and I'll move it over here. If I take the derivative of this, I'm going to get y double prime. And y double prime is going to be equal to x2 prime. But it's also going to be equal to this whole thing. So that's going to be t times the cosine of t minus 4 times, well, what is y? Y is equal to x1, x sub 1. So then I can rewrite these two close together, and I can say that y is equal to x1, and I can say that, sorry, no, I want to look at these. I want to look at these equations over here, because these are the terms of my vector equation. Now I can say that x prime sub 1 is equal to x2 prime, and I can also say that x2 prime, sorry, x2 not prime, and that x2 prime is equal to minus 4x1 plus t times the cosine of t. Now, since I want to impose order on the system, what I would like to do is I would like for this to be, I kind of have to line them up. So let's say I line them up. I move this, and I get the x2. I get plus x2 here by itself. So I'd have 0, x1 here, and then I have plus 0 here, and here I'd have 0, x2. Now, I notice that I can actually rewrite this in terms of x1, x2 prime, and these could be a vector matrix right here. And then I can write it in terms of a coefficient matrix, 0, 1, -4, and 0. And then I'd have the vector x1, x2 here, plus I'd have this other vector, 0, and t cosine t. And I could even pull out the t if I wanted to. And I can call this the vector x. And I can call this the matrix A. This is the vector x prime. And I'll call this the vector x plus some function vector of t. And isn't that interesting? Because now I have a differential equation in vector form or matrix form, as they asked. All right, we'll see you next time.